here. So my talk begins with the work of our own governor, Governor Schwarzenegger, who in 2005 announced the Western Governors Climate Initiative. And when he made this announcement, he said the following: "I say the debate is over. We know the science, we see the threat, and we know the time for action is now." Well, when this came out, my husband Ken, who's sitting right here, said, "Naomi, is somebody in Arnold's office reading your work?" Well, that would be nice, but I don't think that that, in fact, was the case. Many people, many journalists, many scientists have been trying to make the point that we do, in fact, know the science for some time. In fact, in 2004, Discover magazine wrote an article on the top 10 scientific stories of the year, and the number one of the top 10 was the confirmation of global warming. And Discover called 2004 the year that global warming got respect. The point is that in the last 2 years or so, the American people have clearly gotten the message. A poll that just came out a couple of weeks ago from the Yale Project on Climate Change, taken in conjunction with the Gallup polling group, now shows that 72% of American citizens are completely or mostly convinced that global warming is happening. So this is quite an amazing statistic. It shows that the scientific message, in fact, is getting through to the American people. In fact, 62% of respondents believe that life on Earth will continue without major disruptions only if society takes immediately and drastic action to reduce global warming. Indeed, even many former contrarians have come around in the last year or so. One of the most interesting conversions that's taken place is that of Frank Luntz, the Republican strategist. Luntz said last year in an interview, "It's now 2006. So that's a good sign. He got the first fact right. And he went on to say, "I think most people would conclude that there is global warming taking place and that the behavior of humans are affecting the climate." Some of you will remember that Frank Luntz is the strategist who wrote the now infamous memo to Republican candidates in which he urged them to use the phrase climate change rather than global warming because he said, quote, "Climate change is a lot less frightening than global warming." He said that in order to win the global warming debate, the political debate, that Republican candidates should emphasize the scientific uncertainty and insist that there was no scientific consensus. He argued in this memo, and all of the underscoring in italics and bolds here are his own. He wrote, "The scientific debate remains open. Voters believe there is no consensus about global warming within the scientific community. Should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate." Now, this was in 2003, but of course the scientific community had something rather different to say. In 2001, the IPCC, the Intergovernmental Panel on Climate Change, which is the largest international organization dealing with climate issues, in fact, one of the largest international scientific collaborations ever in the history of science, in 2001, in their third assessment report, they stated unequivocally that human activities are modifying the concentration of atmospheric constituents that absorb or scatter radiant energy. Most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. That was in 2001. But in fact, the scientific community had actually already come to a consensus that global warming was beginning to happen in 1995. In the 1995 second assessment report of the IPCC, the scientists involved came to the conclusion, quote, that the balance of evidence suggests a discernible human impact on global climate. Now, in the last year or so, I've spoken to a lot of journalists who ask many questions, but one question that they never seem to ask is, who are the IPCC? And why was this organization ever created in the first place? And how did they already know in 1995 that climate change was, in their word, discernible? The IPCC was established in 1988 by the United Nations Environment Program in collaboration with the World Meteorological Organization, a scientific organization that goes back to the 19th century that was established to facilitate the exchange of scientific data around the globe. But the creation of IPCC was a response to something quite specific, and it was the scientific predictions that were made in the 1970s that global warming due to greenhouse gas emissions was likely to become a serious problem. These predictions were the culmination of 50 years of scientific study. Now, it may be the case that Americans have only now gotten the message, but in fact, the scientific case has been building for more than 5 decades, arguably even longer. So let me tell you just a little bit about that scientific case. For many of you, I know this will be reviewed, but I think it's worthwhile being clear about what the scientific evidence really is. So we know that the Earth is warm, our planet is warm, because of greenhouse gases in the atmosphere. Greenhouse gases are constituents like carbon dioxide, methane, and water vapor, which are very transparent to visible light. So sunlight comes in through our atmosphere very easily, but these gases are less transparent to heat, to infrared radiation. So when light comes in, it warms up the Earth, and then some of that warmth is re-radiated to space, and some of that is trapped by the greenhouse gases in the atmosphere. Now, this is a good thing overall, because if there were no greenhouse gases in the atmosphere, our planet would be much, much colder. In fact, it would be something like the Moon or Mars, much, much colder planets. So greenhouse gases by themselves are a good thing. But as we all know, there can be too much of a good thing, and that's the problem that some scientists began to think about after the work of John Tyndall. It was Tyndall who first established that carbon dioxide was a greenhouse gas, that it had this distinctive property, and he did this work in the 1850s. So this is extremely long-established, well-established, uncontroversial science. But in the early 20th century, scientists realized that if carbon dioxide content changed, then the temperature of our planet could change too. This idea is now most famously associated with Svante Arrhenius, the great chemist who's famous, or until recently was mostly famous, for his contributions to chemical thermodynamics. But he also did some of the first calculations of what the effect of doubling atmospheric carbon dioxide would be. And he calculated that if we doubled CO2 in the atmosphere, it would increase the average global temperature by about 1.5 to 4.5 degrees Celsius. So roughly 3 to 9 degrees Fahrenheit. Now, Arrhenius lived in Sweden, so he thought that warming would be a good thing. But other people thought otherwise. And one of the first people to say that it might not be a good thing, that it might be too much of a good thing, was the British engineer Guy Callendar. Callendar was the first scientist to pursue this issue in a sustained way. And the first also to argue that the increase in carbon dioxide was actually already underway in the 1930s. And this led him to the question, if carbon dioxide is already increasing, then is temperature also increasing? And Callendar thought that the answer to that was yes. And he showed that there was, in fact, a very slight temperature increase, appeared to be a slight temperature increase in the world from the 1880s to the mid-1930s. Nor was Callendar alone. In 1931, a scientist named E.O. Hilbert, a physicist, published an article in Physical Review. Again, 1931, calculation shows that doubling or tripling the amount of the carbon dioxide in the atmosphere increases the average surface temperature by about 4 degrees or 7 degrees Kelvin or Celsius, respectively. So the point of this is simply to underscore the fact that the basic physics of the impact of greenhouse gases in the atmosphere was understood in the 1930s. Now, a lot of scientific work got interrupted in the 30s by first the Great Depression and then World War II, but the story picks up again in the 1950s. Now, one scientific uncertainty, a genuine uncertainty that people worried about at this time, was the competing effect of water vapor. Because water vapor is also a greenhouse gas, so many people thought that the competing effect of water vapor would overwhelm any small effect from little tiny increases in carbon dioxide. But this issue was taken up and resolved in the 1950s by the physicist Gilbert Plass. Plass was a pioneer in satellite spectroscopy, one of the first people to use evidence from satellites to study the upper atmosphere. And in doing this, he resolved the absorption bands, this question of what the gases actually absorb, to a very much greater degree of specificity than anyone had before. And when he did this, he showed that the absorption bands of water and carbon dioxide did not, in fact, overlap. And this was a crucial thing to prove because it meant that the carbon dioxide problem was a real one. And it's that insight that really becomes crucial for the work that then begins here in San Diego, and two people whose names will be familiar to many people here, Hans Suess and Roger Revelle. In 1957, Suess and Revelle published a now famous article in the scientific journal Tellus, in which they said that humans were performing a great geophysical experiment. What was that geophysical experiment? And it was this, that fossil fuels have accumulated on Earth over the course of hundreds of millions of years of geological time. They represent a kind of stored energy, almost a bank deposit of energy. But now, in the 20th century, or beginning in the end of the 19th century with the Industrial Revolution, humans had begun burning those fossil fuels at a very rapid rate, and were putting back into the atmosphere over the course of just a few decades carbon dioxide that had been stored over the course of hundreds of millions of years. And Revelle and Suess had the insight that this was an unbelievable thing to be going on, and that it could have very significant consequences. When Revelle did talk to public audiences about this issue, he did make clear that he thought it was potentially a grave issue. In 1957, he gave an interview with Time magazine, and the article was written up under an article entitled One Big Greenhouse, and the article ran like this. If the blanket of carbon dioxide in the atmosphere produces a temperature rise of only 1 or 2 degrees, a chain of secondary effects may come into play. As the air gets warmer, seawater will get warmer too, and carbon dioxide dissolved in it will return to the atmosphere, possibly raising the temperature enough to melt the ice caps of Antarctica and Greenland, which would flood the Earth's coastal lands. Dr. Revelle has not reached the stage of warning against this catastrophe, but he and other geophysicists intend to keep watching and recording. And of course, that is exactly what they did. The CO2 inventory became the life's work of Charles David Keeling, and Professor Keeling asked the central and key question, or one of the key questions in this whole story, how much of the carbon dioxide being released by burning fossil fuels will go into the atmosphere as compared to how much of it might be absorbed by the oceans or taken up by plants in the biosphere. So Dr. Keeling began measuring carbon dioxide very, very carefully, and within a very short period of time, by about 1965, it became clear, based on his data, that roughly half of the carbon dioxide was going into the atmosphere and staying there, and it was leading to a detectable rise in just a few years. And so by 1965, a number of Professor Keeling's colleagues began to think, well, yeah, here's the evidence of the carbon dioxide inventory, that carbon dioxide is, in fact, staying in the atmosphere, not being entirely dissolved by the ocean, and possibly could lead to serious effects. Now, the 1957 Time article concluded, when all their data have been studied, they may be able to predict whether man's factories, chimneys, and auto exhausts will eventually cause salt water to flow in the streets of New York and London. In fact, by 1964, scientists were making that prediction. And one of the first committees to take up this issue was a committee of the National Academy of Sciences led by the geophysicist Gordon MacDonald, who also taught here at UCSD for a period of time. MacDonald headed a committee of the Academy entitled Scientific Problems of Weather Modification, a report of the Panel on Weather and Climate Modification. Now, this was a group of scientists who were asked to study the question of weather modification that the U.S. government was interested in for agricultural and military purposes. But in the process of evaluating these data and thinking about whether it would be possible to deliberately change weather for military or other purposes, MacDonald and his colleagues realized that it also might be possible to change weather and climate by accident, that